Here's quite a short but lovely little task that I like to use when comparing fractions. So I quite like it because it looks quite a scary question when you first look at it. And I remember the very first time I saw it, I went straight to an algebraic approach and getting a common denominator of n times n plus 1. But it turns out that's using a sledgehammer to crack a nut, and there's a really nice way you can model the solution using cues and air rods. Okay, so the standard way of representing fractions using cues and air rods is to just place the numerator directly above a denominator. So if I'm going to choose this light green rod here to be my numerator, or m, then this black rod here I'm going to choose to be my denominator, or n, I'm going to place the two directly on top of each other. Now the nice thing is, I could have chosen any two colour rod here at all. I've just happened to choose this light green and black one. So this represents the fraction m over n. Now, the reason I like cues and air rods for this particular part of the task is because we can now build the second fraction along. We can build m plus 1 over n and see what actually happens to the fraction. Well, the denominator is staying the same, so we're still splitting the whole into the same amount of parts, but my numerator is increasing. I have one more of them, so it makes sense that this fraction here is larger than this fraction here. This is m plus 1 over n. The denominators are staying the same, but my numerator has increased, so therefore this fraction must be larger than this fraction. And now let's look at the last fraction in the list then. So we've got m over n plus 1, and again we can build it really easy using our cues and air rods. So my numerator this time is staying the same, but it's my denominator which we're increasing. So we're splitting the whole into more parts. So although my numerator has stayed the same relative to this middle fraction, the whole has been split into more parts. So the fraction that I have must have decreased. So this fraction here, this m over n plus 1, must be smaller than the original fraction. So there we have it. We've arranged all three fractions in order of size without the need for any sort of algebraic manipulation. So I really like this because once pupils get their head around this task, you can be sure that they've got a slightly better understanding of what's actually meant by the numerator and the denominator of a fraction. So hopefully you enjoyed it, and as always, post any thoughts and comments in the thread below.